Hi there. In today's lesson we're going to talk about functions. A function is a map which takes a number and maps it onto another number. For example, you see here the number 2 is mapped onto the number 6 and 5 is mapped onto the number 15. We write functions like this. F of x, in this case, is equal to 3x. That means that f of 2 is equal to 3 times 2, which is 6. So we say that 2 is mapped onto 6. We can also write it as a pair, 2 and 6. We can also write f of 5 is equal to 3 times 5, which is 15. And that gives us the ordered pair. So with every function, we have an input number and we have an output number. Let me label these. This is the number we input and this is the output. And in our ordered pair, we have an input, which is the first number, and we have an output, which is the second number. Now there are many different types of functions. Let's give a few examples. You could have f of x is equal to x squared, in which case we would say that f of 3 is mapped onto 3 squared, which is 9. That gives us the ordered pair 3 and 9. Now let's label this as our ordered pair. It's called an ordered pair because the order is important. The first number is the input and the second number is the output. Another way to write a function is we could say f takes x and maps it onto, let's say, x squared. Another way again is we could say y is equal to x squared. In this case, our ordered pair 3 and 9, well, the 3 is the x coordinate and the 9 is the y coordinate. So the order is very important in our ordered pair. Remember that. The first number is the input and the second number is the output. And the idea of having an x and y is that we can then plot it on an x and y axis, where the inputs come from the x-axis and the outputs are on the y-axis. So a number, let's write the function f of x is equal to x plus 2, and let's take f of 1 is equal to 1 plus 2, which is 3. So that gives me the ordered pair 1 and 3, which if I wanted to plot it would be, let's say we go 1, 2, 3, 4 and 1, 2, 3. So there's number 3 here and there's 1. So there's the point 1 and 3. So that's how we can plot a point which satisfies a function. The input is the x and the output is the y. The input comes from the x-axis. We go across to the input, which is 1, and we go up to the output, which is 3, and we plot our point. In the same way, f of 0 is equal to 0 plus 2, which is 2. So 0 is mapped onto 2, and that's this point here. And so on and so forth. In fact, this will end up being a straight line, which you can plot like so. Now there are a few key words that you need to know about functions. So let's draw another little map here. Have a look at this diagram. This shows a function, and the inputs are on the left. The set of possible inputs here are 1, 2 and 3. We call this the domain. And it is the set of 1, 2 and 3. It's the possible inputs. On the right, we have the codomain, which is 3, 4, 5, 6 and 7, and that is a set of all possible outputs. But we also have a thing called a range. And the range is just 3, 5 and 6. Because these are the actual outputs. The set of all actual outputs. So there is a distinction between the codomain and the range. If you see a mapping like this, the codomain is all of the possible outputs, whereas the range is all of the actual outputs. Finally, one very important point. In the definition of a function, a point must be only mapped onto one other point. So an input must only have one unique output. The function on the top here is fine, because 2 has only one output, 4. It doesn't matter that -2 is also mapped onto 4. What matters is that each input has only one output. This function, by the way, is, let's call this g of x. It doesn't matter what letter comes before. So sometimes if you have more than one function, you might call one of them f of x and one of them g of x. So let's call this g of x, which is x squared. So g of 2 is 2 squared, which is 4. But g of -2 is the square of -2. And when we square a minus number, we always get a positive number. So that's 4 as well. Now this is okay. It's all right to have two different inputs mapping to the same output. But down below, we have a mapping where 9 is mapped to 3 and 9 is also mapped to -3. Well, this cannot happen. This means it is not a function. So this is not a function. The definition of a function says that each input must have only one output. Just so you know, this function here would perhaps look like h of x is equal to the square root of x. So the h of 9 is the square root of 9, which is plus or minus 3. So we have a choice. So the really important point to note here is that each input must have only one output. So this up here is a function, because each input has only one output, whereas down here you see 9 is mapped down to two different numbers, so this is not a function. That completes the introduction to functions. In the next few videos, I'm going to give you some examples of linear functions and quadratic functions, and I'm going to show you how to plot them. I hope you'll join us for those videos. That's all for now.